All right, the data below represent commute times in minutes and scores on a well-being survey. Complete parts A through D below. So find the least squares regression line, treating the commute time as x as the explanatory variable and the index score y as the response variable. So I'm going to go ahead and open this up in StatCrunch. And let's go ahead and find the equation. So come down to regression, simple linear. X is x and y is the well-being. And we're going to go ahead and get the fitted line. I'd like to look at that first, to be honest. So let's look at this first. And yep, it looks like our model is going to be pretty good, right? So let's come on back. Let me show you on the TI how we can get this. So on the TI, we're going to press Stat, Edit, and let's clear out my list. Just scroll up and press Clear and Enter. Scroll over to the next one, Clear and Enter. Okay. And put in your list. So I'm going to put in 5, 15, 25, 35, and so on for L1, and we're going to put in the well-being index for L2. So my data's in there. Let's go ahead and do a stat plot. So second stat plot. It's already on, so just press zoom 9. If it weren't on, let me go back there again. You would need to press enter, turn it on, make sure scatter is selected, X list L1, Y list L2, etc. So zoom stat number 9. And there we go. So now let's go ahead and run our regression. I'm in StatCrunch. I'm in the TI right now, so let's go ahead and do it from here. Stat, calc. I'm looking here at my form. It is in the AX plus B, so I'm going to select number 4. I can store that regression equation just so I can see that line going through. I like seeing that line. So I'm going to go ahead and press vars. Scroll over to yvars. It's a function, and I'll just put it into y1, and then calculate. And there we go. Let's see how this compares to StatCrunch. So here it is in StatCrunch again. I ran the regression already, so there is my equation. Let me bring this out a little bit. So here's our commute time. So it's going to be 0.09. We're saying 3 decimal places, negative 0.096. And that's what I have here for A, right? Negative 0.096. And the B is 69.006. And I get 69.006. Okay, so the B part here, interpret the slope and the Y-intercept if appropriate. This one is interpret the slope. So a little confusing how it's written. So this is interpreting the slope, and then the next one I think is going to be interpret the Y-intercept. Okay, so what's our slope? We have a negative 0.096, so we know that for every unit increase in x, in this case it's commute time, so for every unit increase in commute time, right here it looks like D, the index score falls, right, because it's negative, by 0.096. If that had been positive, it would have risen by 0.096. So the second part is the y-intercept. Think about what this means, right? The y-intercept is when x is 0, when the commute time is 0, if you're not having to commute. I think we could probably interpret that. It's not too far out of our bounds here, right? If we didn't have anything close to 5, like a 15 or 25 were our nearest commute, probably wouldn't want to interpret that. 5 doesn't seem too far away. So for every unit increase, nope. For a commute time of 0, when x is 0, that's going to be my well-being score. So for commute time of 0, my well-being score is predicted to be 69.006. So now predict the well-being index of a person whose commute time is 30 minutes. So here's our equation here, and we want to predict at 30 minutes, what will we expect their well-being score to be? So we're just going to put a 30 in for X. Notice if you're over here on if you're using the calculator, when I graph this, there's my equation there. If I look into my y equals, there's the equation. So I could just plug that in, right? So I can go to vars, y vars, function, and then I can put my 30 in there, and that'll work. A little trick on the calculator. You could have just said negative 0.096 times 30 plus 69.006. And if you look at the rounding here, looks like we may be off in the thousandths place. I don't think my stat lab is going to make a big deal about that. Let's check it out though. Good, it just says round to 1 decimal place, so we should be safe. 66.1. Suppose Barbara has a 20-minute commute and scores a 66.2 on the survey. Is Barbara more well off than the typical individual as 20-minute commute or less? So let's find out what would the average well-being score be expected to be. So I'm going to put in a 20 to my equation. I already have the equation here, so I'm going to go, I can press second, enter, and just come up here and change that 30 to a 20. 67.086. So hers is less than that, right? So no, Barbara's less well off. The typical individual has a 20-minute commute, has a commute score of 67.1. So that one had a lot going on. I hope that helped.